we are going to simplify, and now we have radicals. We haven't done this stuff with radicals yet, so it's the same stuff we've been doing. Just have some variables. I said radicals. I meant variables in it too. I'm going to highly suggest when we do simplifying, and we've got numbers and variables, that we separate them. We use our product rule that says that we are allowed to write the cube root of 64 times the cube root of y to the 6. I would highly suggest we go ahead and start by separating those. And then just kind of look at them differently. We're going to look at the numbers differently than we look at the variables. The cube root of 64 Okay. We are in our notes from that we've been working on the past 2 days. We're just on the first example. Really fast off to the side, if you don't have this handy, because I know some of you don't, because then I'd say, oh, where's that list? And you say, oh, I didn't write it down. If you don't have this handy, maybe let's jot this down. 2 to the third, 3 to the third, 4 to the third, 5 to the third. Let's jot down 2 to the fourth, 3 to the fourth, 4 to the fourth. Just in case these numbers keep coming up over and over and over again, we have them handy. What is 2 to the third? 8. 3 to the third? 27. 4 to the third? 5 to the third? Thank you. Somebody else, 2 to the fourth? 16. 16. Somebody else, 3 to the fourth?
81.
You're not somebody else. Does anybody have 4 to the fourth memorized? Or can find it real fast?
260.
It's 256. I think that's what I heard. 256?
What is that?
Mm-hmm. 216 is 6 to the third. That's 216. Okay, so we have some of those handy. I'm going to come back to this rule that's in the chart in a moment. Let me just finish up this example. All right, so now, if we need to find the third root of 64, is that something that is a perfect cube? It's what to the third? So that part becomes 4. Now, when you have variables with exponents, I think it is easier to simplify it if you change it into the variable to the fractional exponent, the 6 over 3. Why did I put 6 over 3? Why did I know to put 3 on the bottom? Because that's the root, and roots go in the ground. So when I look at the 6 and the 3, I know 3 is the bottom number. And then 6 is the power. Sometimes power lines are up there. Power lines, they used to be, like when I went to high school, it was always power lines over roots. But now they put power lines in the ground. So. It doesn't matter, as long as we remember the root. All right, what is, and this is multiplied, what is y to the 6 over 3? It reduces to y to the second. And since we are multiplying, I just put these next to each other. Okay. So we left off here. Now there is a rule when you have variables that you always need to check at the very end. There is a rule that you need to check at the very end. And yesterday when I taught this, that's the rule everybody kept forgetting. And then they'd lose a check on their homework every time because they'd check it and they'd forget about this rule. So we're going to do better. We're going to remember. There's this rule that if the if the index, the root, if that is an odd root, right here, when n is odd, if this number is an odd number, the rule does not apply. We don't have to worry about it. If n is an even number, we have a rule. I'm going to rewrite this rule just a teeny bit different than how they have it, but the rule is if we have an even root